Hello and welcome to Geometry 2D Figures. In this video we will find the area and perimeter or circumference of triangles, rectangles, squares, and circles. That includes those that are on the coordinate plane using the distance formula and Pythagorean theorem to calculate side lengths and the radius, for composite shapes, and real-world scenario models. Here are some of the standards we're going to be covering in this video. These are from the Florida's Best Standards for Mathematics. So let's go ahead and get started. So we are finding the area and circumference of both of these circles. And notice that I have the distance formula and some formulas for circles here at the top. These are straight from your reference sheet on for your EOC. So you don't have to remember them per se, but you do need to remember how to use them. On your formula sheet, it also tells you that C stands for circumference, R stands for radius, D is for diameter, but you still would have to know what those things are. All right, so we are going to use the distance formula with this first one, and then we're going to use the Pythagorean theorem for the second one to find the radius. So sometimes when you are given a circle, the radius is from the center to the outside of the circle. And the radius would be the same all the way around because a circle is the set of all points equidistant from the center. So sometimes it's really easy to kind of count the radius, but notice that the radius is not going all the way to that corner, and so it's 2 something, it's not quite 3. So for these particular circles, we can't just count the radius. You also cannot just count this as 2. That is not 2. And so when we count, we can only go down the squares or over. So just kind of be careful. All right, so we're going to use the distance formula for this first one. Now, it doesn't matter which one you use as x1, y1, x2, y2, so I'm just going to put x1, y1, x2, y2, and here's my distance formula up here. So for my distance formula, and get used to writing out your distance formula. A lot of people don't put the numbers in the right places, and so that's where they kind of go wrong with this. They think, oh, well, it's too long, so I don't want to write everything. So especially while you're learning, make sure you're writing out your formula first. All right, here we go. So with our distance formula, we're going to start with our x's. So I've got x2 minus x1. So that's going to be 4 minus 2 squared plus, and then y2 is going to be 1 minus y1, which is 3. And it might also help when you guys are using your distance formula, and I'm just going to write it over here just real quick. It might be easier to kind of set it up like this, and then plug in your numbers. That way if you have any negatives, it makes it a little bit easier. So we'll do another one like that soon. This one didn't have any negatives, so we're not going to worry about it. All right, so for this, we've got 4 minus 2 squared plus 1 minus 3 squared. Now I can type this whole thing into my calculator, but just for now, we're just going to do it piece by piece. So 4 minus 2 gives me 2 squared plus 1 minus 3 squared. Now, make sure that you're keeping the answers in parentheses. You don't want to take them out of parentheses while you're squaring. And so that is now going to be 4 plus 4 equals the square root of 8. So for this first one, the radius here is going to be the square root of 8. To show you how I would put this whole thing in my calculator, make sure you're using parentheses because we do have some groupings here. For this particular calculator, you don't use parentheses just for multiplication, but for groupings you do. So we've got parentheses 4 minus 2 close parentheses squared, which is this button right here, plus open parentheses 1 minus 3 close parentheses, and then you're going to hit this squared button again, and then don't forget to hit equals. And so we typed everything that was in this highlighted area, and so that's going to be 8. Alright, now let's take a look at our formulas. So we've got circumference is equal to 2 pi r, and so that's going to be 2 times pi times the square root of 8. If you are looking for the exact answer, you would simplify your radical, and then you would multiply your two numbers here and put those in the front. And so 2 times the square root of 8 would be the same as 4 times the square root of 2, and then we would just leave pi on the end. So when we put our answers in terms of pi, this is called our exact answer, and then you would put your units on the end. But we're just going to go ahead and put this in our calculator. We are rounding for the nearest tenth. So in my calculator, I'm going to do 2 times, and then you have a pi button here, and then times, and then for this particular calculator, you put the number that's in the radical first. So 8, and then hit your square root button. Don't forget to hit equals. And we get 17.77. If we're rounding to the nearest tenth, we want one number behind the decimal. So we're looking to see if that 7 would change that 7. And 7 would bump this up. And so this is going to be 17.8. And then because circumference is basically your perimeter of a circle, it only has one dimension, which is length. And so this is just going to be centimeters. Now let's go ahead and calculate the area. So area is going to be pi r squared. So we have pi, and then we're going to replace r with our square root of 8 squared. And if you have worked with the Pythagorean theorem before, you know that a square cancels out a square root. And so these end up canceling each other, and we end up with 8 times pi, and you're always going to put that other number in front. So if we were doing the exact answer, it would just be 8 pi and then centimeters squared. But in this case, we're rounding, so let's go ahead and get out our calculator. So we're going to do 8 times pi equals, and we've got 25.13. And we're rounding to the nearest tenth. So 3 is not going to change 1. And so that's going to be 25.1 centimeters. And then area has two dimensions, which is length and width. And so that's going to be squared. So for that first example, we used the distance formula. I, however, like to use the Pythagorean theorem, especially if I have a graph. If I have only points or coordinates, then I use the distance formula. But if I have a graph like this, I tend to just use the Pythagorean theorem. So for the Pythagorean theorem, we know that it's going to be a squared plus b squared equals c squared. And we use that with right triangles, right? And so what I'm going to do is I have my 2 points here, and I'm going to create a right triangle with those 2 points. Okay? And so I'm just going down and over to create my right triangle. This is going to become A, so that's 2. And then B is just 1 unit over, so that's going to be 1. And so I would use that as A and B. So now I have 2 squared plus 1 squared equals C squared, which is going to be my hypotenuse here on my right triangle. And so that's going to be xy squared. And then to get xy by itself, I'm simply just going to take the square root of both. And so now I end up with the square root of 4 plus 1. And so xy is going to be the square root of 5. So I like using Pythagorean theorem. I think it's a little bit faster, especially if I already have a graph. And so with this one, I'm going to go ahead and do my circumference, 2 pi r, 2 pi times the square root of 5. If I was doing my exact answer, I would just put these two together. 5, the square root of 5 can't be simplified, so it just stays like this. So if they were asking me for my exact answer, it would be 2 times the square root of 5 pi. And I'm going to go ahead and put that in my calculator. So I'm going to move this over. And now I'm going to press 2 times, then make sure you hit what's underneath the radical first, so 5, then hit your square root button, and then times pi, and then always make sure that you hit equals at the end, and it gives us 14.04. And if I'm rounding to the nearest tenth, I only want one number behind. 4 is not going to change a 0, and so this would be approximately 14.0. So just kind of be careful when you are rounding. We don't want to necessarily put equals. We want to change these to approximately. And then circumference only has one dimension, which is length, and so that's going to be centimeters. For area, we have area equals pi r squared. Pi times the square root of 5 squared. And remember, this is just going to be 5 pi. So that would be my exact answer. I'm going to go ahead and plug this into my calculator. So 5 times pi equals, and I get 15.70, and so that's just going to be 15.7 and then centimeters squared. And so this is how we can use both the distance formula and the Pythagorean theorem. If you have a graph, I would use Pythagorean theorem, but if you only have the points, maybe consider using your distance formula instead. All right, now let's do a real-world example. So it looks like we have a flower here that is shaped like a circle. And so we're going to go ahead and find the area and circumference. Now, they give us the distance that is all the way across. That and goes through the center. And so that would be the diameter. So the diameter is 5. And remember, radius goes from the center to the outside. So the radius is half of 5, making it 2.5. So now when we do the circumference, we've got 2 pi r. That's going to be 2 times pi times 2.5. And then remember, we just multiply these two. And so 2 times 2.5, or notice that we have this here that we could use. Circumference is equal to pi d. And so we get pi times the diameter. And then we could leave it like this for our exact answer, but let's go ahead and get it into our calculator. So we've got 5 times pi equals, and we have that 15.7. And then centimeters. And then for our area, we have pi r squared. So pi times 2.5 squared. And so we're going to put that into our calculator. 2.5, remember squared is here. So we get 6.25, and so for our exact answer, we would have 6.25 pi, but we're going to go ahead and put that into our calculator. So times pi equals, and we get 19.63. And 3 is not going to change the 6, and so that's going to be approximately 19.6 centimeters squared. Now let's go ahead and move into some triangles. Now on your reference sheet, there are no formulas for triangles, as they are expecting you to remember those. So for the area of a triangle, you have 1/2 base times height. And the reason why it's 1/2 base times height is a triangle is basically half a rectangle, and we know that a rectangle would be base times height for the area, and so that's kind of where that formula has come from. And so it's going to be 1/2 base times height for the area of a triangle. So let's go ahead and just kind of rewrite this. Area of a triangle is equal to 1/2 base height. And with both of these triangles, it's easy to see the base and the height. Your base and the height are always going to be perpendicular. So B and H of a triangle are perpendicular. So we've got a right triangle here, and this side here is easy for us to count. That's going to be 4. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 going down the side from 9 to 1. All right, and so now from here, for the area of this one, it's just going to be 1/2. And then it doesn't matter which one you put as the base and the height. So we're just going to do 4 times 8. If I was kind of doing this with mental math, 1/2 of 4 is 2, and then times 8 is 16. And so this would be 16, and then centimeters squared. To put this in your calculator, what you want to do is make sure you put your fraction in parentheses. So we have parentheses 1 divided by 2, close parentheses, times 4 times 8 equals 16. Okay. All right. Now let's do our perimeter. So we've got 2 of our sides, but we're missing the 3rd. And recognize that this is a right triangle already, so we can just go ahead and use our Pythagorean theorem to find BC. So we've got a squared plus b squared equals c squared, and we're going to use 4 and 8 as our 2 sides, and our hypotenuse is BC. And then from here, you're just going to take the square root. And so I'm just going to type everything that's underneath here and put that into my calculator. And so I've got 4 squared plus 8 squared equals, and that gives me 80. So this is going to be the square root of 80 is equal to BC. And I'm just going to leave it like that. And then for my perimeter, I'm just adding all of these together. So for my perimeter, I've got 4 plus 8 plus the square root of 80. Let's go ahead and put that into our calculator. So I'm just going to clear. 4 plus 8 plus 80, then hit your square root button for this particular calculator, and we get 20.94. And that 4 is not going to change the 9, and so this is going to be approximately 20.9 centimeters. And perimeter, remember, is just length, so it just only has one dimension. Alright, and now let's take a look at our other one. So with this one, the height is here, and so we can see that our height is 4, and then we've got this going all the way across, and so our base for this triangle is going to be 6. So area for this one, real easy, 1/2 base times height. So our base is going to be 6, and then our height is going to be 4. 6 times 4 is 24, and then half of that is 12. So easy to calculate on our own. And that's going to be centimeters squared. And then for our perimeter, so we've got the bottom, so we know that P is going to be 6 and then plus AC, which is going to be this piece here, and then added to AB, which is going to be this piece here. Now, I could do the distance formula with these. However, I have 2 right triangles going on here. And so I'm just going to use those for now. So I'm going to take this 6 off so we can see it a little bit clearer. So for this triangle that's on the left here, I have one side that's going to be 4. And I'm actually going to move this. So perimeter is going to be AB plus BC plus CB. And we already know that BC is going to be 6. And so now let's do the Pythagorean theorem for this purple side, which is AC. So we've got A squared plus B squared equals C squared. And I have 4 already for one of my sides. And then here I've got another 4. And so that's going to be like that. And that's going to be AC. And then from here, I can take the square root of both sides. Sorry, that should be AC squared. And then I can go ahead and put this in my calculator. So I know that's going to be 16 plus 16, but let's go ahead and practice. So 4 squared plus 4 squared equals square root of 32 is equal to AC. So that's going to be this side here. And so this one right here, sorry, I put BC, that should say AC, is going to be the square root of 32. And now let's find AB, which is this orange side here. So we're going to use the Pythagorean theorem again. So for this one, we've got A squared plus B squared equals C squared. And we've got 4 for one of our sides, okay, which is this one here. And then on this side, we've got 2. And so 4 squared plus 2 squared equals AB squared. And then I can take the square root of both sides. That's going to be 16 plus 4, so that's going to be the square root of 20 is equal to AB. And then for my perimeter, I'm just going to put all of this into my calculator. So I'm going to clear that out, and we've got 20 then square root plus 6 plus 32 square root, and then don't forget to hit that equals at the end, and that's going to be 16.12, and so that's going to be approximately 16.1 centimeters because it's just length. And now let's do a real world scenario. So it looks like we have a sailboat here and we are calculating the area and perimeter of this triangle. So with the perimeter, they already gave it to us, but notice that it has feet and inches. So when we're doing the perimeter for this one, we've got 14 and then 7 inches is out of a whole foot. And so that's going to be 7 over 12 when we write that out. So 7 inches is going to be 7 out of the entire foot, which is 12. So for perimeter, it's going to be 14 and 7/12. Then we've got 13 and 4/12 plus 13 and 4/12 again. And then for this one, remember when we are plugging in mixed numbers into our calculator, we're just going to read this as and. So don't forget that there's little plus signs in between here, and that we put parentheses around our fractions. So if you need to put that on your paper to kind of remind you of how it needs to look, go ahead and do that. All right, so we've got 14 plus 7 divided by 12, close parentheses, plus, now don't get bogged down looking at the numbers as you're typing. Okay, open parentheses, 4 divided by 12, close parentheses, plus 13 plus open parentheses 4 divided by 12, close parentheses, make sure you hit equals at the end, and we get 41.25. So 41.25, if they asked me to round, this would be approximately 41.3 feet. However, I can go ahead and transfer this into inches. And so what you would do is you're just going to take this part and multiply it by 12 because this is a quarter of a foot. And so 0.25 times what would be 1 foot is just 3 inches. And so this would be 41 feet and 3 inches. And then for the area, don't forget that the base and the height are always perpendicular. So notice that they gave us these two here. And so for our area, it's going to be our base, 1/2 base times height, 1/2 times our base, which is 14 and 7/12, and then our height, which is 11 and 2/12. And I can just type this whole thing in the calculator. I'm going to add parentheses around my 1/2. Don't forget that there's little plus signs here. And so when I type this in, clear this, parentheses, 1 divided by 2, close parentheses, times, parentheses, 14 plus 7 divided by 12, close parentheses, times, parentheses, 11 plus 2 divided by 12, close parentheses, and then equals. And that gives us 81.42. And so we're going to keep that as is. And that's going to be 81.4, and then feet squared. 0.42 out of a foot is not going to come out as nice as this, and so we're just going to keep it as a rounded number for this one. Now let's go ahead and switch gears a little bit, and we're going to do some parallelograms. So we've got a rectangle on the left, and then we've got a square here on the right. And they do give you that the area is base times height. And so let's go ahead and do Pythagorean theorem with the one on the left, and then we'll do a little bit of the distance formula with the one on the right. So let's go ahead and start with this one. So with this one, I'm looking for my base and my height, right? And they're not so easily measured. I can't just count this. And so I'm going to use the Pythagorean theorem. So just like before, I'm going to create a right triangle with those 2 points. And so from here to here, I'm going 3 here on the side, and then 1, 2, 3, 4, 5, 6 here on the top. So a squared plus b squared equals c squared, and I'm going to use 3 squared plus 6 squared equals dc squared, and then I'm just going to take the square root. So I love using Pythagorean theorem on these because they're way faster. And then I'm going to type this into my calculator, and I know that 3 squared is 9 and 6 squared is 36, but I'm going to type it anyway. So we've got 3 squared plus 6 squared, and then always make sure you hit equals at the end, and that's going to be the square root of 45. So now for these, this is the square root of 45 here, and that makes this also the square root of 45 on this side as well. And so that's how we find one of the sides. And then I'm going to make another triangle here. So I'm going to find AD, which is this side here. I'm going to create another, in fact, I'm going to erase this so it doesn't get in our way. So for this one, I'm going to create another triangle here. And I've got 2 on this side, and then I've got 4 on this side. And let me put DC on here. All right, and so a squared plus b squared equals c squared, and I've got 2 squared plus 4 squared equals AD squared. And then I'm going to take the square root. And I know that that's going to be 4 plus 16, which is the square root of 20. And so this is the square root of 20, and then this is the square root of 20. So now this makes it a lot easier to do my area and perimeter. So area is going to be base times height. So I've got the square root of 45 times the square root of 20. And we could do 45 times 20, put that underneath the radical, go from there. But we're just going to use our calculator. We're not going to do simplifying of radicals today in this video. And so we're going to do 45 square root times 20 square root equals, and we get straight 30. Okay, and the reason for that is 45 times 20, I could put them both under the radical, and that would be the square root of 900, which is just 30. And so the area for this one is going to be 30 centimeters squared because it's area. For the perimeter, we have 2 times the square root of 45 because we have both of these long sides here, and then plus 2 times the square root of 20 because we have these two sides here from the orange. And so now I'm just going to type this into my calculator. And so clear. So 2 times 45 square root plus 2 times 20 square root. Then make sure you hit that equals at the end. And I get 22.36. And that's going to be approximately 22.4 because the 6 is going to make that 3 go up. And that's going to be centimeters. So now let's move on to this square. And with a square, we know that all of the sides are going to be the same. So it makes finding the area and perimeter real easy. And so we've got area would just be one of the sides squared. So S squared. And so we really just need to find one of those sides. Now, for the perimeter, it's going to be 4 times one of the sides, and then we would go from there. So let's go ahead and calculate what one of these sides are. Now, this would be super easy using the Pythagorean theorem, but I do want to show you what it is to use the distance formula. So remember, it doesn't matter which one you label as x1, y1, x2, y2. We're just going to pick two of these that are next to each other. So I'm going to choose like that. Then for our distance formula, and so that's going to be our distance formula is equal to the square root. And so I want you guys to write down your formula just while you're learning. That way you're not putting the wrong thing in the wrong spot. Okay, and there we go. All right, so we've got our x1, y1, x2, y2 labeled. We wrote our formula. Now, when I go to plug these in, and I kind of mentioned this earlier, it might be easier if you kind of set it up like this. And this will help you with plugging in negative numbers. So now from here, x2 is going to be 3, and then x1 is 5, y2 is negative 5, and then y1 is negative 3. Now, this makes it so much easier when dealing with negative numbers to kind of view it a little bit easier. And this is going to be the length of EF. Well, technically, FE. And to make this easier on myself when I go to put this into the calculator, notice that we have two negatives next to each other, so we can change that to a plus here. And that way we're not doing minus and negative in our calculator. We can just type it with that plus sign instead. So I'm going to clear out my calculator. Parentheses 3 minus 5 close parentheses squared plus open parentheses 5, then we're going to make it negative using this plus to minus button, plus 3 close parentheses squared, and then equals, and we get 8. And so that's just what's underneath the square root, so don't forget our square root is still there. So one of our sides is the square root of 8. So that means for the area, it's going to be the square root of 8 squared, which is just going to be 8, and then centimeters squared. For our perimeter, it's just going to be 4 times the square root of 8. So let's go ahead and put that in our calculator. So 4 times 8 square root equals, and we get 11.31. 1 is not going to change the 3, so that's just going to be 11.3 centimeters for our perimeter. Now let's go ahead and take a look at a real-world example. So we have this van here, and they're giving us the length and the height of this van. So we've got perimeter is just going to be 2 of our length and then 2 of our height. So we've got 2 times 14.8 plus 2 times 16.25, and then let's go ahead and get that into our calculator. So we've got 2 times 14.8 plus 2 times 6.25 equals, and we get 42.1 feet. Super easy. Then we've got the area, which is just going to be base times height. So we've got 14.8 times 6.25. Let's clear this. 14.8 times 6.25 equals 92.5. And then remember, area has 2 dimensions, which is length and width, or base times height, or length and height. And so that's going to be 92.5 feet and then squared. So now let's go ahead and jump into a real world scenario. So in this scenario, we have a bakery sign, and for part A, it is asking us how much of the green trim is needed to go around the perimeter of the sign. So we're talking about the outside here. And I'm just going to go ahead and redraw this. It looks like we have a combination of 2 different shapes here. We've got a rectangle, and then we've got this semicircle at the top. So I'm just going to go ahead and create the full circle here. It doesn't have to be perfect, but this makes it a little bit easier for me to digest and work out on my paper. So I've got 2 and 2. This is 3.5, which makes this also 3.5, and then we've got 7 here along the bottom. So building out my perimeter, I know that I already have these pieces ready to go. So this, I can go ahead and add up for a portion of my perimeter. So I've got 2 plus 2 plus 3.5 plus 3.5, and I could also write that as 2 times 2, 2 times 3.5, and then I've got 7. But now I'm missing this top piece here, which is half of my circle. So I'm going to go ahead and just kind of draw this circle out to the side. Okay, and if this entire length here is 7, and I've got 2 on this side and 2 on this side, that's 4, I know that the inside here has to be 3. And so with my circle, I know that the diameter is 3. So now I can use that to find this top piece of my sign. So this, the perimeter of the circle, is called the circumference. And so we have a formula for circumference. We can either use pi d or 2 pi r. We already have the diameter, so I'm just going to use the diameter. So the circumference is going to be pi times 3, or we would just write that as 3 pi. And then remember, this is only half of the circle, so for this piece here, it's going to be half of that, or 3 pi divided by 2, or we could write that as 1.5 pi. And so now I'm just going to put that here. So the circumference would be all the way around, and we only needed half, so we took that 3 pi and then we divided it by 2, which is 1.5 pi. And now I can go ahead and get this all into my calculator. And I've got 2 plus 2 plus 3.5 plus 3.5 plus 7 plus 1.5 times, and then I can use my pi button here. And then don't forget, this is just showing pi. Make sure that you're pressing equals at the end, and we get 22.71. And then you would round this however they ask you to round it. And so we might say, if they're asking to the nearest foot, we would say 23. If they asked for the nearest tenth, we would say 22.7. So it just kind of depends. And I'm just going to put feet on there. Let's go ahead and move to part B. So part B says the front of the sign is to be covered in a sealant. How much area needs to be covered? Round to the nearest square foot. So I have our diagram here, and if we're looking for area, we're looking for the inside. So the easiest part of this is to go ahead and find the inside of this rectangle here. And we know that the area of a rectangle is going to be base times height, or length times width. And so the base of our rectangle here is 7. And then the height of our rectangle here is going to be 3.5. And so we're just going to go ahead and pop that into our calculator. Clear it out. 7 times 3.5 equals, and we get 24.5. So we get 24.5 for the inside of this piece. And then we're also looking for the inside of this semicircle. And we already found the diameter in part A. And our formula for the area of a circle is pi r squared. Well, we don't have the radius, but we do have the diameter. The diameter was 3. So in this case, if the diameter is 3, the radius is going to be half of that. So it's going to be 1.5 because it's only going from here to the outside. And we can go ahead and plug that in. So pi times 1.5 squared. And let's go ahead and get that into our calculator. And so I normally type pi at the end, so I'm going to put in 1.5 squared and then times pi, and then make sure you hit equals. Now remember that we had the entire circle that we calculated for our area using our formula, and we only want half of that. So the area of the entire circle would have been this 7.06858, but we want to divide that by 2, so we're only taking half of our circle. So we're going to say divided by 2 equals, and that's 3.53. I'm looking for the nearest foot, so I only need the tenths place to make a good decision, and so I'm just going to put 3.5 here. So it gave us 7.068, and then it gave us some change, but we took that and we divided it by 2 because we only have half the circle here. And that's going to give me 3.5. And now I'm just going to add these two together. So I've got the area of my rectangle here, I've got the area of my semicircle, and so the area is going to be equal to 24.5 plus 3.5, and that's going to give me 28 feet. And we went ahead and routed that to the nearest square foot already. Okay, so 28 square feet is how much they would need. Now, if you're doing a problem where they said the entire sign would be covered in sealant, remember the 28 feet, that is only the front of the sign. If we were dipping the entire sign into sealant, you would have to multiply that by 2 because that's the front and the back. So just kind of be careful about word problems like that. All right, and then it says if the sealant covers covers an area of 20 square feet, how many pints of sealant do you need? Well, 20 would cover most of it, but we would need 2 pints because we're not going to take this and divide it by 20 and get a decimal, because you're not going to walk into the store and say, oh, can I only get half of this sealant? Can you pour part of this out? And so that's going to be 2 pints. 2 pints is going to cover 40 square feet, which is going to be definitely enough to cover 28. Let's go ahead and try another real-world scenario. It says the world's largest ice cream cake was created on May 10th, 2011 in Toronto, Canada. The cake was 4.5 meters long, 4.06 meters wide, and 1 meter tall. Just by this description alone, there's different shapes of cakes, but the fact that they said the length, the width, and then the height, that kind of tells me that it is a rectangular prism or a rectangular cake. Okay, and so all the surfaces of the cake except the bottom were covered with a cookie crumble topping. Use an appropriate two-dimensional model to approximate the area covered by the cookie crumble topping. So if they had told us maybe the diameter, that would have signaled that we are talking about a circle cake, but in this case we're talking about a rectangular cake. So I'm going to go ahead and draw my cake, and it doesn't have to be perfect, but we're going to draw a rectangular prism. Okay, doesn't have to be super fancy, but we know kind of what it's going to look like, okay? And it's telling us that it is 1 meter tall. And so this piece right here is going to be 1 meter. And it is 4.45 meters long. So that's going to be here. And then wide, we've got 4.06. And if we're talking about the cookie crumble topping, we're really talking about surface area here. And in thinking about the surface area, if I am talking about the front of our cake, okay, we know that that is going to be 1 meter again here. And to find the area of that front piece of our cake, and so if it helps you with kind of breaking down surface area this way, the front of the cake is going to be base times height, right? And so that's going to be 4.45, and then it's times 1, so it's just going to be meters squared, okay? And the back piece is also the same. So the front and the back piece are the same size. So between the front and the back, we're just going to take this and we're going to multiply it by 2. And then if we're talking about the side pieces, okay, that's going to be 4.06 and then times 1, which is its height. And we've got 2 side pieces here. And so we're going to multiply that by 2 as well. And then we're not putting crumble topping on the bottom. That would mean it would be sitting on crumble topping. And so now we're just talking about this top piece here. And we know that that top piece is going to be 4.45, and this is going to be 4.06. And so the topping is going to be 4.45 times 4.06. And so don't be afraid to just take surface area piece by piece, especially if you're missing one of the sides, say that you're missing the top or missing the bottom, and you're not feeling quite comfortable with using formulas that are given to you, just take it piece by piece. And so for the surface area, so I'm going to put SA here, for the surface area of this cake, we've got 4.45, and we were multiplying that by 2. That was the front of the cake and the back of the cake, plus we've got 4.06 times that 1, and that was the sides, and so there's 2 of those sides, plus the top, which was 4.45 times 4.06, and we're only doing the top, so we're not going to multiply that by 2, and then we're going to go ahead and just get all of that into our calculator. And so I'm going to clear out my calculator, and I've got 4.45 times 2 plus 4.06 times 2 plus 4.45 times 4.06 equals, and we get 35.087. And it's asking us to round to the nearest tenth of a square meter. So I only want one decimal place. And so is that 8 going to change the 0? Yes, it's going to move up. And so our answer is going to be 35.1 meters squared. All right, we've got another real-world scenario here. We have a 400-meter Olympic-sized track, can be modeled with a rectangle and a semicircle on each end. And so it says if an athlete runs around the track once, then how far has the athlete traveled to the nearest meter? So they gave us this distance here, and this distance here, that's the field that's kind of in the middle. And so if we want to, we can kind of clean this up. Okay, and we've got 2 semicircles here on the outside. And of course, I'm not tracing super perfect, okay? And so it says if an athlete runs around the track once, then how far has the athlete traveled to the nearest meter? Well, I know that this top piece is also going to be 84.39. And so for the perimeter, it's going to be 84.39, and we can put it as plus 84.39, or we can just multiply it by 2, because that's the top and the bottom of our shape. But then we also have these semicircles here. And so if I were to put them together and just create that circle, this is 73, and that's going to represent the diameter of the circle. So the diameter, as it goes from one point to the other, is 73, and we're looking for the perimeter of the circle, and that's called circumference. And so let's go ahead and calculate the circumference. So we know that the circumference of a circle, I'm just going to put it over here. And we already have the diameter, so I'm going to use pi d. And so that's going to be pi times 73, or 73 times pi. Let's go ahead and get that into our calculator. I'm going to go ahead and clear this out. And I type pi last, so 73 times pi equals, and that gives us 229.34. And remember, we have half of the circle here on this side, and we have half the circle on this side, and so we can just keep it as that entire whole circumference there. So we can just add these two together. Oops. And that's a 4. And then let's go ahead and get that into our calculator. I already have this here, so I'm just going to put plus 84.39 times 2 equals, and we get 398.1, and it says round to the nearest meter, and so that's just going to be 398 meters. And then it says, what could explain the difference between the length that you calculated for part A and the actual length of the track? And so when we're looking at this, this would be the perfect scenario if the person running was literally on the very edge of that grass there. If they were on the very edge of that grass, if they were on the very edges of these semicircles, then it would be 398 meters. However, we know that people are running here, and so that's where we're going to have a little bit of a difference. And so this is if it was a very, very perfect world, and if they were only running on those very edges. We have to account for the distances away that they are running from those edges. Now let's go ahead and jump into part C. So part C says each lane is 1.22 meters wide. So we're kind of imagining that the first lane is going to be 1.22 meters wide. And then if the athlete is running in the center, you're really only adding 0.61, which is half of that distance, 0.61 meters on this side, and then you're adding 0.61 meters on this side of that 73. And so if we're calculating our new distance, the straightaways are still going to be the same. So we've got two of those, but then that diameter on those semicircles are now increasing from 73 meters to 74.22. So we're adding on that 1.22 meters onto 73. So now we're going to recalculate our circumference, which is pi d. And for the diameter, it's now going to be 74.22 times pi. Let's go ahead and get that into our calculator. So 74.22 times pi equals, and we get 233.16. So I added this onto here, and that is going to be 233.16 meters. And so now we've got 84.39 times 2 plus that 233.16. And so let's go ahead and add that. And we get 401.9. And then it says round to the nearest meter, so that's about 402 meters. And then it says, how far inside the track should the athlete be positioned to run exactly 400 meters? And then it says, round your answer to the nearest centimeter. And so instead of us calculating this all the way out, when we were just doing the 73 meters, right? When we had our diameter at 73 meters, we were at 398 meters total for the perimeter. When we added 1.22, we added another 4. Okay, we added 4 meters here. And so if we only wanted to add 2 meters to that original, that means we're just going to add half of this. And so that would be 73 plus 0.61 equals about 400 meters total. just so we're adding 2. But remember that that was cut in half, right? That was how much they were adding on to each side. So in this case, we would want to cut that in half again to figure out where they're positioned. Here, they're positioned at an extra 0.61 meters away from the edge on both sides for the addition of the 1.22 meters. For this one, we would be adding on about 0.3 meters. And so in this case, they would need to be positioned about halfway between that 0.61 and that regular 73. So that would be 0.3 meters is where they would need to be positioned to run exactly 400. And then of course you could plug that in and check it out and see if that works. Let's go ahead and jump into our last real world scenario for our video. And right here we have a rack of 15 pool balls, and it says what is the area contained by the rack, round to the nearest tenth. So area of a triangle is going to be 1/2 base times height. So that's going to be 1/2, and then the base is 11.5. And then our height is 9.96 inches. And so let's go ahead and get that into our calculator. And when I am putting fractions in my calculator, I typically put them in parentheses. That just helps your calculator make sure that it's keeping the right order of operations. So we have open parentheses, 1 divided by 2, close parentheses, times 11.5 times 9.96 equals, and we get 57.27. 57.27. And then if we are rounding to the nearest tenth, we want 1 decimal place behind. That 7 is going to round that 2 up, and we're going to end up with 57.3 inches squared, because we're talking about area. And then it says what is the approximate area covered by a single ball, round to the nearest tenth. And so we're just going to take this area and we're going to divide it by 15. We're not going to account for all of this space in between. There are ways for us to figure out a little bit deeper as to what the area of each ball would be, but we are just going to do 57.27 divided by 15. And we get 3.818. And then if I'm rounding to the nearest tenth, that 1 is not going to change the 8. And so that's going to be 3.8 inches squared. I hope you found this video helpful in working with 2D shapes and our real-world scenarios dealing with 2D shapes. This is definitely something that you want to cover before moving into 3D shapes and working with those formulas, and I will see you in the next video.